Some application you can click on animations, non-linear statistics webinar, flight control of a drone, so object recognition. So you can give so many projects to your students. Simulation, wind speed analysis, and if you proceed further, so deep learning using cafe model, electromagnetic with the simulators, how to develop application in Scilab. Some data sets are there. XCOS, if you are work with the Simulink in MATLAB, same XCOS is there. How to build a toolbox, optimization, signal processing, and now deep learning, image processing, character recognition, machine learning, and data mining, and so many topics, so many applications are there. Computer vision. So let's say randomly, I'm now clicking on one of the link. So let's say I've clicked on deep learning. So all the code and data sets are given here. How to work in the Scilab. So how to load the model, how to do the model information and running the forward pass. So you can see these screens. I will show you in MATLAB, in Scilab. All these windows I'm going to show you. Then this is about the code, etc. And now if you see the current hot topic about the like coronavirus. So if you click on the, if you want to do some prediction on coronavirus, or we want to do some modeling, so we some GUI, graphical user interface, are available. We can fetch the data, and even on the GitHub, this code is available. Time series dataset is available, and using image processing techniques, this can be processed. And this is the model for spread out disease, whether it's a suspectical, infectious, or recovered. So all these things can be done in Scilab. So now what is the first step? You need to download. I hope all of you might have downloaded the Scilab. So again, please reply on the chat box. How many you have among you have downloaded? Please write yes or no. Then according to your operating system, whether you are on Linux, Mac, or Windows, you can download, and as per your architecture, whether it's 32-bit or 64-bit. So for the best of the time, I already have, okay. So already I have downloaded, or you can do later on. Now what you need to do, I am opening here one notepad. I am going to write the instructions. And later on, I will share with all of you. I'm going to save this. First, we'll talk on Scilab installation instructions. I will try to increase the font. So I hope you can now see the instructions. Now after downloading this Scilab, like in my case, I already downloaded in a folder, like in download. So it will be zip. Then you right click and extract here, unzip it. This is the first step. You will get this folder. In this, there is a folder by the name bin. Under this bin, there is a command Scilab. So you need to run this. First step, unzip and go to bin folder and write the Scilab. So dot slash means current path and then give the Scilab, or you can give the full path. So now I'm going to show you how to open the MATLAB, Scilab. So CD, we can go to that folder, downloads, Scilab. So in Linux, you just press the tab, automatically it will cover the command. Now I have not typed the full, automatically when I press the tab, automatically it came. Now we are here using pwd command that we have seen in the morning session. Present working directly, we can see here home, username, downloads, Scilab, and this is the bin directory. And using ls, we can see what are the things. So we have to run this Scilab. So we have to use dot dot means current directory, and then give the name Scilab, and it will open the Scilab. So now up to here we learned two things. Just download the Scilab, extract that, that means unzip that, and just run the command Scilab in the bin folder. So now it will open the Scilab. It will take a few seconds. It is opening. So now you can see this Scilab. Scilab is ready with some certain windows are there. So this is the current path. This is a console. This console is just like your if you have worked with Python or MATLAB. If you have worked, so now let's say I want to do some just I want to use as a calculator some number and multiply with some other number, random number. So we'll get the result. So whatever we are doing, this is a command history, and if we are not saving in a variable, it will give by default variable is answer. So for example, now we want to see the value of pi. There are certain keywords like pi is 3.1. Okay. I will try to zoom it. I will try to increase the font size. So here in the preference, I will increase the font size. So under option, under preferences, set font. So using this, we can increase the font size. So let's say I have changed to 36. And for console also, let's say 36. So here I am typing something. Can you read? Is it okay? Is it okay? Okay. So now when you launch this Scilab, you have one editor where you can write your program, SciNotes. It is known as SciNotes. So how to launch it? How to launch this? So to launch this, there is a icon here. I am closing this. On the left side, this is the launch SciNotes. So we have to write our program here. SciNotes, and we can start writing here. And okay, now I'm opening the presentation and we'll start working with the Scilab. And after that, I will show you around more than 600 engineering books are available. That code is available in Scilab. So now I'm opening the presentation. So any query how to launch the Scilab? It's very simple. Just unzip, go to the bin folder and write this ./Scilab. Dot means current path, or give the full path, or you can give the full path /home/username, and you can give that also. So now after that, I'm going to show you. I'm opening the presentation and I'm going to demonstrate you. Okay, there is a one comment, just you have to unzip. So now we want to plot certain two-dimensional and three-dimensional plot, or we want to do something, and we will share all the presentations with all of you. So now what we are going to do, we are going to take two variables. Just I'm going to show you the power of the Scilab and how to work on the Scilab. So we are taking two variables and we are assigning certain values. So let's say so I'm minimizing the browser. Now first we'll try to understand. Let's say we want to generate odd numbers between 1 and 20. So how we can generate the odd numbers? We can say odd, and we know the odd numbers will be 1, 3, 5. So it's an increment of 2. Now what it will do? So 1 is the initial step, 20 is the final step, and 2 is the increment. 2 is the increment. So now we can see the output is 1, 3, 5, 7, 9, like that. Now we want to generate the even numbers. So how we can generate the even number? Using the here, we can write even equal to 0 colon 2, 2 is the increment, and 20. So we'll get this. So in this what we are doing, we are getting the points 1, 2, 3, 4 up to 10. So this is the starting point, increment of 1 and 10. And we are getting some equation and trying to plot this. So simple, we can copy and paste in our console. So now we can run here also, the same thing we can do here also. But when we close this program, so our program will not get saved. So it is recommended to write in the side notes. So we'll write here and we'll save our program file, save as. Just like in Java, we saved by the name .java. In MATLAB, we save by the name .m. In Python, we say .py. Similarly, for Scilab, we use SCI. The extension is SCI. So it's asking where you want to save your program. So here we will make one folder, or we can go to the home folder. We can go to the desktop where we have created this Scilab, and we can give the name program, whatever the program you want to write here, and the extension will be SCI. Extension is SCI, Scilab program. So already there is a program by the name program 1. So I am writing here program 2 or whatever is appropriate. Now how to run this? There is an icon here. Just click this and it will give the output. So what we did in this program, we took two variables x and y with certain values. X we initialize the value in between 1 and 10, and in y we gave the some equation and we try to plot this. So just in 3-line code as shown in the presentation, as shown here, we can easily plot. So you can see it's too easy as compared to other programming language. And we need not to define the data type, automatically it will take care. So if we want to give some color, font size, the labels, easily we can do. So how to do that? So simple, we'll copy this. So again, we have the same variable x and y. Now we are giving title x label and y label. And then we can open this. We can write the program and run it. And whatever we want to modify, we can modify, we can change here. So now here you can see x and y label, and this is the title. So easily you can generate this. Now we'll see further. So you can see to generate sim plotting x and y and give the title. There is another option. We can give x title, x and y graph, x axis and y axis. So instead of giving title as a separate line, x label as separate line, y label, we can use x title, and we can give this will be the title, the next will be the x axis, and next will be y axis. Same thing we can do in other way. And also when we copy paste from other editor, we have to take care of the Unicode. Here the characters I am giving here. So whenever there is any mistake in typing or something, that also can be edited. And if there will be any no output, you can see on the console, you will get the output. So it's showing here at line number 4, of executed home. There is an issue of X title, axis, and this. And here we can give now you can see. Now what was the issue when we copy paste from the PowerPoint presentation? So the ASCII code, the characters was little different. So I overwrite this. So when we share the presentation with all of you, when you are trying to run this, and if you get some problem, just the problem will be of like comma, apostrophe. It's better to write in Scilab and remove the previous one. So now when you want to plot multiple, that is also possible with some legend value. So there is an inbuilt function legend. If you are comparing certain values, if you are doing some research, if you are doing some publication, and you want to publish your result, so just you write title, X label, Y label, and legend. Same thing you can what you might have done in the Excel. So when you save and run, so again the problem came of this apostrophe. So now again we can rectify this. So here, and we have to mention here the same program, and here let's say we have used the end of line. So it's now executing, and now we got this output. So here we got the function evaluation. So when you are doing some kind of research, some publication, you have to present your results. So you can see just in few lines, according to your equation, you can plot wonderful graph, and you can even export this into JPEG. You can save file in different formats or export as. You can click on export or file save as. Click here. You can save in JPEG, PNG, or different formats are there. So now up to here we understood it's very easy to work with the graph. Now if you are working with multiple experiments and you want to show like ROC or some other multiple graph on single graph, so there simply you write this is a one variable, this is another variable, this is your equation, and now you are plotting this with the function and with cosine function. So now here I am just running this now program. What we did, we now took one variable with the values of 1 and 1 to 10, another variable with the sine, and another variable with cosine. Now we are plotting with respect to sine and with respect to cosine. So now we can see sine and cosine. Now, for example, you don't want to run sine, so there you can use clear figure, CLF. If you want to show only one, then you can use CLF. So you will find only one. So in this way, we can work with plotting 2-dimensional and 3-dimensional, and you can do superimpose or you can use clear figure. Now this is another, even you can beautify. You can beautify your lines with the red marks, with blue marks, how you want to show. So after this, in the next slide, we'll see what are the different options are available with us. Now in this program, plot with, earlier we used only plot function. Now what we are doing, R means red color, and how we want to make dotted line. Now B for blue line. If you want to make black, then you can use K, and star for, like, it will plot like this. So you can see now if we have the red line with the dash, simple line, as we have not used the CLF, so it's showing the previous one also. So before that, we have to use CLF if the previous figure was there. And then if we write, the previous will go away. So now you can see we have used a clear figure, and now in this way we can plot. So what are the different options are available with us? We can use blue, green, red, magenta, yellow, black, white, and all these marker and style line and styles we can use. Solid, dotted, dash, dot, and dashed. All these are these things are there. Now in this line we are going to plot xy and xy with the blue and with O. So simple. We will write and run it. So here you can see we have plotted the x and y, and now before this it's better to use CLF to clear the previous figure. So now we have plotted in this way x and y. So x and y with red color with dash, then again xy with blue color and with O. So now what are the other options are there in plotting? So in this way we can plot. We can give the locations. We can use our logarithm scales. So what this linear space say, in between 1 and 10 we want 10 points. We want 100 points. So using the linear space we can easily plot this. So if you have worked with the MATLAB or Octave, that you will learn, this is the inbuilt function. What it will do, in between 1 and 10, it will create 10 points. Now on the console, I will show you. Now this is the console. CLC for clear the console. And here linear space, let's say in between 1 and 2. How many points we want? We want 20 points. We can say linear space in between 1 and 2. 1 is the starting point, 2 is the final point, and how many points we want? 20 points. So it will generate 20 points in between 1 and 2. So same we can do with the log space. And for further information, you can use help and the function name, like linear space. In this way, it will open the function and it will show you intensive help is available. So you can see with the examples, lot of help is available inbuilt. So when we run this command, now, and now here we are using not simple plot, we are using here plot 2D, two dimensional. So we'll get the output like this. And as already there were previous CLF. Now we got the plot in two dimensional, plot 2D. So similarly now we can do with the linear space, we can plot two dimensional and we can give these kind of things. So also we have different axes we can mention which allow to control the size of the axis. We have this function. Now if we want to set the grid, we can set the grid, we can run like this. There is another option, you want on the same window multiple plots. So there we can use subplot. So what does it mean? Two rows and one column. 2, 1 means two rows, one column. This is for the first, this is for the second. So how it will look like? So now we'll try to understand the subplot. Now what we are doing, we are defining some values in X variable. Same on that we are now assigning to Y1, Y2. So that means total how many rows are there? Two rows. And how many column is there? One column. And this is for the first figure, this is for the second figure. And we can run it now. So now two rows and one column. Now instead of this, if we want to show one row, two columns, that means we want figure next to this. So what changes we need to do? Simple row and column. One row and we can run here two columns, and here one row and two columns. So this will appear on the first column, this will appear on the second column. So instead of like it showing in this way, it will show next to this. So now we are going to run, we will run this, and space is also important. Now this space is also important. So one row, two column. So there is a typo mistake at line number 3. We have to use the X. So these errors will appear at the backside, at the console. So what is the learning here? You can write the program in the side notes and run it. And if there will be any error, it will appear on the console. So it's showing now syntax error, unexpected bracket, expecting end of line at line 3. 1. Okay, we are defined y1 sine, we are defined cosine subplot 1. Okay, cosine cos x. Now we'll save and run this. It's trying to run the program. So now this is the output, and we'll clear the previous one. How to clear the previous figure? CLF. So now what is the learning here? If we want to display four figures, so how we can display four figures or six figure, so that can be controlled by these parameters. So first parameter is for the row, second parameter is for the column, and third parameter is for the figure number. If we want to display four figures, so we can use 2 by 2, 1, 2 by 2, 2, 2 by 2, 3, 2 by 2, 4. In this way we can show. So now we understood how to display the images horizontally as well as the vertically. So any doubt, if because this is very important, subplot is going to help you when you have to run multiple results and you want to display on the same figure. So in case if anyone has any doubt or any query, they can unmute or they can write on the chat box. So next is what we want to display the frequency table. Now 6 is occurring how many times, 7 is occurring how many times. So we can do the histograms. So histogram will show the distribution of the data and it will plot the frequency. So it's very simple. We have initialized certain values. So you can see we are plotting this data and we have given the bins. So now what are these bins? We'll see now. And again, we'll clear the previous figure, CLF, and we'll plot this. So here, how many bins we have given? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now I'm going to give the 5 bins. So that will give you better understanding. Now we have given the 5 bins. Now let's say I've given here 2 bins. So entire data we're going to represent in 2 bins. Now if I give here 12, so it's going to adjust the data in 12 bins. And if I give, let's say 20 bins, so that doesn't mean your if you give 100 bins or how many bins you want to adjust your data. So it represent -10.1, then -1, then like this. So let's say we want to have this data in 5 bins. So in between -10 to -6. So it will take the minimum range, maximum range, and it will take 5 bins. So let's say minimum is -10 and maximum is, let's say here in our data, it's around value is, it's a negative, it's a 0.15, I think. No, it's positive 15. So minimum is -10, maximum is 15. So it will, that is the range. It will divide into 5 bins and try to adjust and plot accordingly. So in between -10 and -6, these many points are there. In between -4 and 8, these many are there. In between these and these many points are there. So in this way, we can plot the histogram. So it has many applications, especially in image processing. When we want to reduce the noise, if the image is not clear, we want to perform histogram equalization. We can see, and using the histogram, we can see whether the image is totally dark or on the white side. So the pixels pointing towards 0 are more on the darker side, and pixels more on the brighter side are on the right side. So now we want to generate the bar. So for making the histogram, the command was histplot, and to generate the bar, we have the bar. Now after this, I will show you the around 600 engineering books that is coded by the IIT Bombay. So whatever the subjects you are teaching, you can adopt those books and start, the codes are available, and start using in your lab. So now we are going to generate the bar plot. And I will clear the previous one. So now what we have done, we want to show the same data in the bar form. So -10 is reflecting in this way, then other points and so on. So 9 is reflecting in this way. So now we understood bar. Similarly, we can generate the pie chart. It's very easy. Let me for the same data. So simple will say pie. I will simply say pie and data. And when we save, it will show. So now there are 4 portions. So it's showing first portion is on around 20. Total is, if we do the total is around, it's 31 plus 17, 48, 48 plus 23, 48 plus 23 is 71. 71. So 23 is around 24%. 15 is this many percentage. This is this much percentage. This is this much percentage. Now, if further we want to do now explode. So what do we mean by explode? So now we want to do explode. So at this we are going to perform the slicing or explode. So now we have started here from this location. So on 1 it's showing 0 0. Let's say I have written here 1. So it will do explosion because we have started from 0 1 1 1. And if we do 1 1 means we want to explode. And again in the help we can see more options. Now we have exploded at each angle. So when we explode at all, it will show nothing. Not nothing, but the values are not there properly. One has been 23, 15, 16 and 17. So now the 4 information we exploded at all the 4 sides. So again using help pie we can make the pie chart. We can do the plot 3D. For 2D we have seen 2-dimensional. For 3D we can see. So now up to here we have learned. It's very easy to, I have deliberately started with the plot 3D. Now I will quickly show you about some syntax, and then we'll move toward the other Python that we can use in our engineering education. So now using this plot 3D, we can easily draw this. So these are the few exercises that you can try later on. Now I am moving toward the second portion of the Scilab. Any question related to 2D and 3D? Okay, if there is no question query, now we'll move toward the syntax. So just like in any other programming language, we have loops, if structures, and other constructs, programming constructs. So same here. So any doubt, question, query, you can write on the chat box. Constantly, I'm looking for the this thing. So you can, in Scilab, you can make the decision, you can do the selection using if loop, loops, and these are the operators: equal to, greater than. Same like in MATLAB, we have tilde sign and equal to for not equal to. In some programming, it is exclamation sign and equal to, not equal to, and remaining symbols are same. And for and or not, the same symbols are there. So if you are familiar with any programming language, it will be very easy to understand. These are the conditions. If this condition, then we execute these commands, then and similarly we proceed further. Else if, even we can use switch statements. Now for example, we have taken this code and display. To print, we can use the command display, or to take the input, we can use the input from the user. So now we have given here the option I equal to 2, 3, 4, any value you can give, or you can take from the user. If so, how this we can use? Let's say you are working on some smart building or some project. There you have taken the input, or let's say driverless vehicle. So you have taken the input from the sensors, or smart building, or in driverless car, if you have taken the input from the sensor, and that sensor is for the, let's say, temperature. There you can put the conditions. If the temperature is above 30, switch on the AC. If the temperature is below 30 degrees, switch off the AC. And in cold areas, you can give, if the temperature goes beyond below 5 degree, or like, switch on the heater. So smart building or same thing you can do using these constructs. So here we are taking some input from the user, and if this is equal to the condition, then do perform these instructions. Else if this equal to, perform these instruction. So you can use multiple else if, and if it doesn't match, then go for this condition. So in this case, it must display goodbye. So now when we run this command, when we run this, so here we are getting the output. So I'm clearing the console. So here you can see the output is goodbye. The output is goodbye. Now I'm changing the condition. Let's say we have given the condition here 3, and if we are running it again, so it must display HI. So here you can see again we got the output HI. And if we give the input as let's say 33, now 33 is not in the condition. So in that case, it will go to the last condition. It will go to the last condition. So that now it must display the good night. So here now you can see the output is good night. You can see it's very easy to use these programming constructs. If else, same we can use the select statement, just like you have the switch statement. So here we have the select, and according to the case, we can print this. So select case A, case B, case C. If it is not on the case, then else. Go to the else and proceed further. Then for loops, we have the loops. 2 loops are there, for and while. So in the for loop, we have the start condition, we have the finished, and we have the steps. So these many steps, it will execute these commands. Or we can use while the condition, and we can press the end. Now let's say we want to display the numbers between 1 and 100. So we can give there 1, step will be 1, and we can 100. If it's odd number, then we can give the step as 2. Similarly, here we can write while I is less than 100, and we can increment I value with the I equal to I plus 2. and using this we can display. So for loop in ascending order, descending order, we can write these are the while loop. We can display these values, and we can use continue break just like in C programming. And so these are the simple programming constructs. Now, the how this is going to help you in your engineering education. So for that, now I'm closing this program. So there is a link scilab.in. I'm pasting the link in your chat box also. There is on the left side, there is a project Scilab text companion project. And this project has been developed by the IIT Bombay. So when you click on the textbook, there will be two options: books in progress and completed books. Earlier, they used to give around 16,000 for as an honorarium for each team member. Now they have some slight changes are there. So now you can click on the books in progress. So around 44 books are in progress that will be available after a few days or few months. So these are the areas: mathematics, electronics, and these are the books are there, which are in progress. Even in computer programming, certain books are there. Now we'll see what the completed books. When you click on the completed books, around 627 books are ready, and you can select from your area. So like majority of the faculty members are from computer science, or as per your area, you can click on those subjects like from computer science, image processing, programming, data structure, logic. These books are available. Or you can scroll down and you can explore all these books. If you are from electrical electronics, and these are the standard books: linear programming, signal programming, control system, electronics, etc. So let's say I am opening here one book on computer science, and let's say image processing. So even though there are two books are available on image processing, one is from Jeraman, another is from Gonzalez. And if you click on this book, the all code which are available in Scilab, just like we did right now, this programming that is available as a code, you can download, or you can download the PDF, or you can select on the chapters, like here image segmentation. Now what you want to do, let's say you want to perform Gaussian filter. So this code is available here. Now how to run this code, you can download, install the Scilab, and that you can run. Now for example, you don't have any, you are not downloaded and install the Scilab. So right now also you can work on your mobile. So how to work on that? Go to this link. Again, I pasted this code, this link in your chat box. The books that we have seen there, these are available at the cloud also. You can write your own code, or you can select from here. Then you can select the subject image processing, like Jeraman, and there we selected one topic on, let's say, image transforms. We want to do find the singular value SVD of a given matrix, singular value decomposition. Now this is a code on the left side. How to run this and how to get the result, just you click on the execute, and you can see the output here. So similarly, if you are teaching, let's say, data structure or your area or some programming, and you have, let's say, data structure book, and under the data structure, let's say we want to perform on the graphs. under the graphs, let's say we want to perform NITTTR algorithm. Now this is a code on the left side. Even you can modify, and then you can run. Here there is a button, execute. You execute and the output will come on the right side. Now this is the output. Now here you want to run your own this thing. So let's say there is a command version. Here you can see the version and it's showing the Linux. It's running on Linux 3.10 and Java. This is the version of the Java runtime and showing the other information. And it's running the Scilab is 5.5. Now whatever I have shown you in the presentation, that all code also we can run here. So let's say in the presentation, I have shown you code on different 2-dimensional, 3-dimensional. So here in this 2-dimensional and 3-dimensional, so let's say randomly we'll pick some code. Okay, let's say we have selected this code and we are now going to run this. We'll simple copy paste here. We can write here and we can execute. So here you can see same output. And then you can download also. If you click on the download, you can download or save file and this is the format PNG and you can save in your local location. So now come back to this. So you can run on the cloud and again we'll see about this. So how to go to this? Go to scilab.in. So here again, you go to this scilab.in. Scilab.in. Then go to the complete textbook companion project. After that, click on the completed books. And these are the books. Now we'll have a look on the books. So we have books in power electronics, linear algebra, physics, control system, fluid mechanics, engineering physics, optical fiber, or you can search also. So these are the 627. Let's say you want to search on image processing. So write image by Gonzalez. This book is also available. If you are teaching data structure, you write data. So data structure is also there. You want to do numerical analysis, digital signal processing, all these codes are available. So these are the standard semiconductor, heat, diffusion, numerical analysis, and etc. All are under open source and common creative. Now the major question arises how to learn about this. So how many among you are aware of this spoken tutorial? Please write on the chat box. I pasted the link. Okay, Mr. Narendra Pal Singh is aware of this. Okay, Mr. Anand Kumar is also aware of this. So there also you can learn the Scilab here. So you can learn about the C, C++. Already most of you Audacity, Bash programming, Python, etc. Now also there you can see the link for Scilab. So you can click on the Scilab, you can select the language. In this language, these has been translated audio file, even Malayalam, Kannada, Kannada. So your students will learn in no time. So in few weeks they will be comfortable with the Scilab, and even they can participate in the hackathon for toolboxes for Scilab. Okay, I left with one topic on toolboxes. I will show you the toolboxes, how to install the toolboxes, and what are the toolboxes are there in the Scilab. So let's say we have selected the language English. So these are the topics: introduction to Scilab, self-learning, the resources, the migration, installing vector operation, matrix operation, conditional branching, iteration, script function, plotting 2D, xcos, file handling, integration, solving non-linear equations, linear equations using Gaussian method, interpolation, and then further ODE applications using Euler method, optimization, digital signal processing, discrete systems, all these things. So because of the time constraint, I'm going to show you only one of the video just for 2 to 3 minutes. So all of you will get the idea and you can do the self-learning later on. So let's say I click on the interpolation. And
dear friends, welcome
is it
to the
audible?
spoken
Please reply.
tutorial
Is it
on
audible? Please
numerical
reply on the chat box.
interpolation.
Is it
At
audible?
the end of this tutorial, you will learn how to develop Scilab code for different numerical interpolation algorithms, calculate new value of function from given data points. To record this tutorial, I am using Ubuntu 12.04 as the operating system and Scilab 5.3.3 version. To practice this tutorial, a learner should have basic knowledge of Scilab and should know numerical interpolation. To learn Scilab, please refer to the relevant tutorials available on the Spoken Tutorial website. Numerical interpolation is a method of constructing new data points within the range of a discrete set of known data points. We can solve interpolation problems using numerical methods. In Lagrange interpolation, we
Sir, you are mute, you are not audible.
Okay, just for 2 minutes, you will see. And later on, you can
then we
explore.
divide the
Now,
numerator
is it audible?
and denominator to
Yes,
get
sir, yes, sir.
L. We use L to find the value of the function y at the given data point. Finally, we display the value of L.
So these are the self-explanatory MOOCs. Very good, very interactive, very simple. So you can and your students can explore these later on. Now come back to the toolboxes and how to install the toolboxes. That is very important and backbone of the Scilab. Because when you download the Scilab, the size is approximately 2 to 300 MB. If you download and install the MATLAB, it required minimum initially 2 to 3 GB. Then it fetch the toolboxes from the internet and ultimately required 30 to 40 GB in MATLAB. and high end of RAM is required. So in here, now I'm closing everything. Now in the MATLAB, in the Scilab, there is this icon. So I'm not in position to make it zoom, but you can see this, the icon yellow. You can click here, and these are the modules. I will see if this could be done. In Windows, we have Zoom It and some other tools. So right now, I'm not aware of the zooming tool in. I'm trying here. Okay. So you have the tools, toolboxes, bioinformatics, data analytics, data handling, domain, graphic, image processing. So when it is not green, that means you need to install it. Now, how to install this? Uh, just click on this toolbox and click on the install. So using this image processing and computer vision toolbox, you can do a lot of image arithmetic block processing, enhancement, transforms, stitching, morphological operation, tracking, super resolution, and then click here. You must it is going to click going to the repositories, and you must have to connect it with the internet, and it will fetch, and within few minutes, as per the bandwidth of your internet, it will be ready. And once it is ready, it will color will appear in the green color. And the site is official website is atoms.scilab.in. So by the time it's installing, you can go to see atoms.scilab.in. Even you can download and install offline. All the instructions are given there. I think scilab.org, not in. Now it's opening. So please note down this official repository or blog. I pasted in the chat box. So you have the data analysis, neural networks, data handling, domain specific graphics, education, image processing, instrument control, optimization, parallel processing related to physics, Scilab development, signal processing, and if you scroll down, and many more toolboxes are there. And if you click on the image processing, so these many toolboxes are there. Okay, there is a one advice to use settings manager. Okay, I will try this magnifier, or I will try here to type once magnifier. It's installing the magnifier. One more information that I would like to share with all of you. There is a one official, there is a one website, distrowatch.com. Under this distrowatch.com also around 400 Linux based operating systems are available, and all these distributions are available here. Now the question arises which we should use. So that depend on the application requirement, your architecture, your hardware. So I am pasting this link. So on your chat box, I have given the link distrowatch.com. Here also you have multiple operating systems according to your hardware or country of origin. Like our own India's own operating system is BOS, developed by the CDAC, Bharat Operating System Solution, and it supports around 22 Indian languages. Even in Kerala, Tamil Nadu, in Punjab, Haryana, many institutions they have deployed, and it's available here. So that also you can select country of origin, distribution category, the operating system type you are looking for, Solaris, BSD, or Linux, or other, or based on the architecture. So many architectures supported by the Linux, Alpha, HP3, Intel, then SH, Sun, Shark, Vex, etc. So the distribution category is important here. Under this distribution category, as per your research area, whether like on the last day we have the topic on Docker, education, firewall, forensics, free software, high performance computing, mobile, multimedia, network area storage as a beginner, Raspberry Pi based scientific. So if you click any of the software and cut the submit, it will tell you the 4 5 options. So these are the 4 5 options are available, which you can install on the distribution on the Raspberry Pi, especially for low-end devices or IoT related devices. Tiny Core Linux, Open Mendix, and all uh, distributions are given here. So even Raspberry Slideshow is there. Focus to display image and video files, digital signage on the Raspberry Pi, display full browser, and many more. So all these things you can explore. And these atoms, under these atoms, we have so many toolboxes are there related to computer vision, IPT, uh, related to education, related to documentation, related to, and it's very easy. Click on that, download, and instructions are given there. Or there is a command also, atom install this, whatever the name is there. So again on their chat box, I am mentioning here. So what we have learned today, we have learned how to install the Scilab, how to work with the Scilab. Then I have shown you some of the power of the Linux. Now you can see the color is green. So that means it is now installed. So I can run all these things, and I can even go to their official website, ipcvscilabacademy.com. Then you can see in at the national level, AICTE and other IIT and many premium institutions, they are planning and they are going to conduct the hackathons for toolboxes for Scilab. And official on the official website of scilab.org, we have seen a lot of resources are there. So many projects are available that we can do in Scilab. And otherwise, the commercial softwares, their toolboxes, very expensive. So students cannot afford them. And using the pirated software is an offense. So we should use always legal software. And last not least, you can go to this link where you can find around 2.5 lakh softwares are available in open source, sf.net. There also you will find Scilab, Octave, whatever the softwares you're looking for, sf.net. And so there are many resources are there. How to learn this now, Scilab? To learn this, we can start with the spoken tutorial. We can start with the scilab.in. Whatever the subjects we are teaching, download those books and start coding those books. And we can perform all kind of engineering, numerical computations, and many more. So all these things can be done here. So now I stop here. Now we'll take the queries. So now query from the participants. Any question, query? If something is not understood, I can repeat that thing. So now any question, query from any participant?